So the other areas that we've been trying to push into particularly are trying to use those same sort of machine learning concepts to apply it in more unstructured environments. So let's forget about mines and things like that, but instead try and get a vehicle to operate in bush areas. Now there may be many applications of this, although these particular videos here are particularly defense context. One could envisage many of these applications being, for example, in bushfire fighting, in forestry, in terrestrial ecosystems and so on, where you actually use airborne platforms, ground-based platforms, build up a fairly complex model for what's going on, and actually use that model to control the outcomes of these platforms. So again, you want to do a lot more sophisticated processing now. So we've got long gone are the days of just using a radar or just using a radar. These images are actually generated from combined laser, radar, infrared, cameras, ultra-wideband radars, extremely rich models of the environment, and on the basis of that being able to distinguish things like trees from bushes, from terrain, from cars, and you can even see a fence and various other things like that in there if you want to actually get these robots to operate in these complex environments. And ultimately one of the goals is to take that and not just deal with data and show data, but to say that that data is a tree, that data is a car, that data is something else, a pedestrian, and so on. So actually interpret this information in terms of something that people or a machine can actually use in a visible form. Here's another interesting outcome, yet another startup company out of the group, and this is really quite a nice application. We actually had I'll explain what it is before we get there. These are sniper training robots, so they run around a training facility. All right, this training facility is in Western Australia, and people shoot them, okay? And they're pretty clever robots because they've got microphones on them, so when they get shot, they actually fall over and look like they're dead, but the other ones run away. All right, so it really makes it a very hard challenge. They go in and out of buildings using all the navigation technology that you've seen in previous projects. They've got all this cooperative control things, so they know how to behave together. You could have one bad guy, 7 good guys, these sorts of things all running around. It was an interesting project because we actually had the generals in the lab and we said, okay, this is what we can do with robotics. What do you actually want? And what they didn't say, what they said was, well, we don't want them for combat. We'd like them for this application, and here are a few others, and so on. So again, this kind of engagement with the end user. And this company not only has now sold them in Australia, but it also, very unusually, has sold a big system to the US Marines. Selling defense technology into the US from Australia is a non-trivial thing to do. And as of last week, they also sold a system to the Jordanians as well. So this is a really interesting niche application of this kind of technology. So let's look at a few other applications. Again, one of the first things I did when I arrived in Sydney was start an underwater vehicle project. If you're coming to Australia, you've got to find some excuse for spending time on the beach, right? But it turns out also we have such a wonderful ecosystem, a huge exclusive economic zone around Australia, that really marine robotics is one of the few ways that you can actually hope to do stewardship, or you hope to do this monitoring and mapping, and indeed other potential commercial applications offshore. So we run this deep submersible. This is about a 1 kilometer depth vessel. It's untethered, but it's got many of the same technologies that I've already shown you. Different sensors, so it's got vision, it's got acoustics in this case rather than anything like radar, but the same type of thing. We want to build up maps, we want to use those maps to do navigation and so on and so forth. We want to build up data information, various other things that the end users of these sorts of things actually want to employ for various applications. So this actually is interesting here. So one of, again, if I didn't show the video again, that robot running around in the corridors, one of the key technologies in that was how you build a map and then use the map to navigate when there's nothing like GPS, right? And SLAM is the technology that does that. It stands for simultaneous localization and mapping. And this is probably the reason that I actually got elected an FRS. Okay? It's been one of the most important contributions probably in robotics in the last decade. And in this case, underwater is another good application. There's no GPS, there's no maps, but what you can do is you can use your acoustic and your visual information. If you look carefully there are red dots and green circles. They're basically the raw information. You can use that information to basically start building up a map, and then as you come round with that map, you can actually do this matching between the different parts of the map, and on the basis of that, you can update the map and update where you are, and effectively continuously build an improved map and figure out where you are at the same time. All right? This really is an autonomy problem. To make a robot autonomous, you want to drop it in and just let it go. And this basically does exactly that. So this is core technology, and we're one of the only people who know how to apply this underwater in this case. It's fairly sophisticated, but nevertheless it's very valuable. And there's a big program, some of you may be aware, IMOS, in which now there's continual observations made all the way around Australia. And we do deployments every year. This is this year's deployments, Ningaloo Reef off Tasmania, and so on and so forth, doing these surveys. So this is the Ningaloo Reef survey. This is a survey off the Barrier Reef looking for what happened in the last time that the world warmed. All right, there are old coral reefs underneath the current coral reefs, and by exploring those and mapping those gives you some sense of what will happen in the future. Here's another very interesting one. This is done, in fact, in the Spencer Gulf off Adelaide, and it's again, turns out cuttlefish are good indicators of pollution. So we send the vehicle out all night, and what it does is it counts cuttlefish. And these are actually quite hard to find because, of course, cuttlefish camouflage themselves, and it is dark. All right? So you've got to use some quite sophisticated algorithms to find out what's going on. So let me just put one other thing here. One of the great things in our group is having a wide diversity of different people all involved. This is actually our media artist. We have a full-time artist who works in the group. This is actually a robot sculpture called Fish and Bird, and it's based on a Greek love poem about how fish and bird fall in love, but they can never be together because they're in different mediums. So this has been quite an interesting project because you've got two robot wheelchairs here. You walk into the environment, and then depending on what you do and what they do, they behave in very different manners. They behave towards you and so on. So these go on exhibit all over the world. We've got about 30,000 subject references now, and this is often the first time people have ever engaged with a robot in an interesting way. And so these robots navigate around depending on what's going on with everybody else, and then they write, you see these bits of paper on the ground, they write different love messages to each other. All right, isn't that nice? So I often ask myself kind of what we did right in this process, and I think there are two big things. The first thing was to come to Australia and focus on a technology for which probably the biggest user in the world is Australia. All right? That's been the biggest success. You look at all the applications I've shown you now, if you were to pick somewhere where you really wanted to apply it, it would be in Australia first. Mining, agriculture, marine systems. Okay, cargo handling's everywhere, but bear with me there, okay? So I think that's very important. The second thing is, with this kind of technology and with the way we engage with industry, is to attract really an amazing group of people. We've grown from 10 people when I was first in Sydney, you might even remember that, Matthew, to about 250 now across the whole group with 120 PhD students. We have to fight them off to come and work on the beaches, with the aircraft, even in mining these days. So it's been a really excellent exercise in really trying to encourage people to take on this kind of technology. So I'm going to stop there and just really say something about what I'm thinking about doing in the next 10 years. I think for us, mining technology is really the big driver. Because there's the investment going on, because there's the need for this type of technology and so on, there will be large investments in trying to make automation, trying to get the value out of automation in mining. And I think it's fair to say that the mining application at this point is probably pushing technology worldwide. There's more sophisticated data fusion, automation technology going on in mining than there is even in the defense field now. And I know because we collaborate a lot with the defense people. I think a second really important application is to take this technology and apply it to environment monitoring applications. I've shown you a number of marine applications, but there's a big interest in doing terrestrial ecosystems, really understanding and being able to steward our environments, getting those sort of data products. So it's not the robot again, it's the way of getting information out of the system and being able to use that in some useful process. And finally, I think there will be societal applications of these. And I think things like the art thing that I showed you earlier, a number of other elements that we're looking at, applications like remote assisted care, bush firefighting, these are really the applications, A, which are drivers in Australia, and B, which I think the technology is now ready and thriving to go with these. So I think I will stop there. Thank you very much.
Don Fry.
Hugh, what have you got planned to help Mr. Obama's oil leak in his Gulf?
That's a good question, and interestingly I've been asked that question at both of the previous talks that I've given. We actually have a guy from our lab in field in the Gulf of Mexico at this time, all right? And the reason for that actually is quite interesting. He specializes in using the robot that we have of mapping benthic plumes, that are plumes that are basically coming up from black smokers. And he's been mapping these for other reasons, actually to find the black smokers in the first place. But it turns out all the algorithms that basically sense that and build models of them and how they flow are exactly what they need for that sort of thing. So in fact, he left last week. He is currently in the Gulf of Mexico doing exactly that. Because I think a lot of the problems are with the dispersants in there, these big plumes are staying underneath the water.
Hi, Vincent Conrad from the NOUS Group. You've got environmental monitoring out in your 10-year window, but you're already flying and swimming around identifying cuttlefish and different things. Why such a long time frame for that to be taken up?
Okay, let me rephrase that. I think it's interesting the way some of our processes work. You know, and maybe you can see it like in the agriculture example I showed you. We get people like defence to fund it, right, and build all the aircraft, and then the farmers who can't afford it can then also, you know, effectively utilise that technology. And to some degree, this is what's been going on in the other areas. The marine stuff, initially there was some defence funding and various other things which got us going, but now it's if you like it, because you're actually now working with biologists, working with people who actually, you know, need that product and can see what you can deliver, it becomes self-sustaining, okay? I think we still have that to go in the terrestrial ecosystem side of things, all right? So we're seeing agriculture applications, so all these different cooperatives. Every couple of weeks, my colleague Salah is off with the banana growers or the cotton plants or whatever else it is, looking at different types of weeds or different types of things. It's not long to think, okay, so now instead of just taking one robot, let's take a lot of smaller robots and actually do a bit more persistent monitoring of that, provide the data that people need to manage that whole process. And again, I had a very interesting talk in Brisbane because we had the cane farmers and various other people who clearly have been thinking along similar lines. Do you know what I mean?
They wanted to know if he could spot cane toads.
Yeah, and then shoot them with a laser. So I think, if you like, it requires the right time and the right people, and the terrestrial side is really beginning to come together. And I think that's very interesting. And you know, when I look at the application in Australia as I fly out to the Pilbara, these huge areas, I mean, the only way of really understanding what's going on will be to use robots of some description and that data fusion technology and so on. The marine side was an interesting lesson because I think there was a user acceptance problem. Okay, because they wanted to, they thought that they could do it by dragging a sled, and they've always done it by dragging a sled. And what could you do that we can't do by dragging a sled? And then we produce these incredible images, and they can do science they've never done before. So you really got to go that extra mile and work with the user. Scientists are just as bad as industry in that sense, right? And equally with farmers, you know, no one was going to pay for the first one, but the moment you can do those, find every single prickly pear and spray it in his yard, right? Then they begin to believe. And you need to do the same process throughout. So I think all of these things you need to, you know, you really need to get that community going, and you need to work very, very closely with that community and understand, you know, what the process is. So I now know what all the invasive weeds are, but you're not credible unless you can do that.
Yeah, Chris Fraser from Minerals Council.
Yeah.
And so a mining-related question, and it's about skills and developing into the future with the automated mine. What are the types of skills that we will need to run these mines, and do we have those type of skills now, or are we going to be upskilling existing employees such as electricians and electrical engineers, or is there some other type of skill set that we don't even know about yet that we should be starting to talk to the universities about?
That's a very good question. I'll preface it by saying afterwards you might want to talk to Andy Stokes, who's at the back, who's our Rio guy, because, I mean, these are questions that they are grappling with themselves. I think it's been interesting, the drill process, how readily the drillers and the maintenance crews have actually adopted it. Do you know what I mean? Or admittedly, they have to have their hands held to start with, but there's a degree of enthusiasm. They're no longer sitting on a drill rig. They're sitting in a comfy cab, or indeed, in principle, they could sit in Perth. You know, so their lives themselves are actually improved. And I think, you know, there's a big plus to that. And we saw that also on the terminal, you know. In truth, Patrick's got the thing right. They were going to pay the waterfront guys by how many boxes they move. And they discover, well, the automated ones move them quicker. And therefore, if we work for the automated ones and help it work, we actually get paid more. Do you see what I mean? So there's a kind of process. So I think the skills are actually there for most of what's required, okay? It may need upskilling, but nevertheless they're there, and the enthusiasm's there as well, providing they're actually brought on site early and properly and so on and so forth. At the other level, though, which is how this stuff gets developed and so on and so forth, yes, there need to be, you know, you will need the electrical engineering graduates, the mechatronics graduates and so on. But it's a different kind of graduate. It's a graduate, I've got to be honest, I mean, I have the advantage of being a Federation Fellow, and so I no longer teach, right? But there is an issue of actually getting our undergraduates to actually want to get out there and do real things rather than just theoretical things, to learn by doing, if you see what I mean. For us, at least at this point, that only happens at postgraduate level. Do you know what I mean? So it doesn't really happen at the undergraduate level, and universities are not really set up to do that. But at the postgraduate level, you know, the guys who go out of here, who go into Patrick's or who go into Rio or whatever, these sorts of things, they are really people who can, frankly, you saw that picture at the end. They can go anywhere, do anything, automate whatever is needed in whatever environment. You know, on the water, in the Pilbara, you know, on the other side of the planet. And that's the kind of skill base that you actually need. And we are generating them, and there's a lot of enthusiasm for it. What can I say? There's going to need to be a lot more, and the universities themselves are going to have to change, in my belief.
Kevin Sanders from Affairs, one of those growers.
Yep.
Just interested from our perspective, how close you are to being able to pick it up.
That's a hard problem. I mentioned having the generals come in to talk. Because, of course, you know, one of my favourite cartoons is a picture of the staircase and a door at the top, and there's a Dalek sitting at the bottom, and it says, "Damn, there goes my plan to conquer the universe." All right? Because we can get robots to do a lot of great things, but getting a robot to climb stairs and open the door is basically never been done. Okay? You just cannot do it. And we once went out to Orange, you know, with the horticultural people out there, and we watched the low-paid student pickers picking, and they can pick like greased lightning. There's no way you could get a robot to do what they do. I mean, it just is. I mean, you could get it to do it, but it just would never be effective. Do you know what I mean? Yeah, look, I've seen them as well, but you see how quickly a person can do it and how efficiently they understand whether that's ready to pick and whether the right thing and how they and everything else. The skill involved in that relative to the technology, relative to something else. I mean, this is sometimes my point is, so I can fly. We have a UAV. It went in South Australia, flew for 100 kilometres, spraying individually every weed. Okay, that's what you want to get a robot to do. Okay, do you see what I mean? So it's kind of finding what the right technology is at the right thing. We're not there in terms of agility, dexterity, other sorts of things. It's a hard thing to do.
Wayne Fitzsimmons, the PSC Foundation. Hugh, have you put your mind to thinking about intelligent transport systems and the application of robotics?
Yes, we have. We've avoided it too. And we avoid it, you know, we have 3 rules, right? When we start a project. Is there good research? Okay. Is it good for Australia first? Okay. And the problem with transport is everyone else is doing it. Okay. So I can go to Germany and Mercedes and everyone else are doing it. Go to Japan and the US are doing it and everything else. So why should we do it? We have all the other things that we could be doing. Do you see what I mean? So it's not that we don't have technology that is valuable for that type of problem, okay, or indeed as someone who doesn't drive and has to use public transport and not even concerned about the problem. It's just that there are so many other good opportunities in which Australia is the biggest and best market already, all right, that we choose to focus on those.
John McDonald, Design Inc. Architects. What about applications in space? I understand there are 450,000 bits of space junk floating around up there. I mean, could we collect that up with...
Again, actually, we do. Actually, we have some space programs. We get funding from NASA and people like that. But the problem with that is you build one robot every 30 years, and you send it somewhere, and it's only one robot, and by the time it's there, it's 20 years out of date. I mean, do you see what I mean? And it's not actually that exciting, in truth, from a research point of view. I mean, I know it looks cool on the TV and stuff. Do you know what I mean? I mean, it's equally, we don't build humanoids. I mean, Japan builds a lot of humanoids. And I always find it interesting, their videos of mine automation often involve, with the exception of Komatsu, because I know someone involve a humanoid sitting in a cab. Do you know what I mean? So that is one way to automate a cab, a thing. Do you see what I mean? So I guess we've chosen things which we feel are going to have an impact in Australia. It's been a very important focus for us. Because that's the way, I mean, that's what. And again, if I can extrapolate, this is why Japan works on humanoids. They're worried about aged care. That's their major driver. Or why the Europeans work on manufacturing and transport, because that's their big driver. And why the Americans just build unmanned drones and things like that, because defence is their main focus. Do you see what I mean? So we've got our niche, and it turns out to be a good niche.
Jamie Ross from miningman.com. So another mining question.
Mm-hmm.
Underground mining versus surface. Obviously no GPS, but much more defined pathways. Yep. Are there insurmountable challenges underground?
In fact, I'd go even further. The underground automation problem, to a large degree, things like LHDs and trucks, is solved. The technology was there 10, at least, if not 15 years ago. The reason it has not been successful is that people have forgot that we didn't want an automated X or an automated Y. We need an automated mine. And that requires thinking when you're building it, how am I going to build an automated mine with everything integrated, the picture, the data fusion, the information, et cetera, and then I'll get the people out of the cabs. That's why it's not worked. And it's been interesting. So many people have tried it, and the technology, it's not the technology that's failed, it's the implementation that's failed. And I think that's a big, lesson that we have all, well, at least I think I have learned it.